Hello students, and welcome to our lesson on completing the square. We really only have two situations where we have to complete the square, so you see our two objectives there at the top. One of the cases is where the a value is 1, and the other case is when a is anything other than 1. And when we're talking about the a value here, remember we're talking about quadratics right now in this section of our class. So if you look at our application, you see 3x squared minus 12x plus 9. The a value is the 3, which is the leading coefficient, or more specifically, the coefficient of the x squared term. So this 3 right here is our a value in the application, so that would be an a not equal to 1 case. But we will also see ones where a is equal to 1. And essentially, we treat both cases the same, just if a is not equal to 1, we have one extra step, depending on how you look at it, maybe two extra steps. Okay, so why do we need to know how to complete the square? Well, our application tells us the main reason. In college algebra, which is the class after this, you'll need to complete the square in order to write quadratic functions in what is known as vertex form. We will actually be doing this in lesson 26 in this class, and so even though you need it for college algebra, you also need it for this class, so important to learn. And the reason we want to put things into vertex form is because this allows us to easily see how the function has been transformed from the toolkit function, which is just plain old x squared. So vertex form of a parabola looks like what's in the bottom right here, a times x minus h squared plus k. And what we're going to learn later on is that h is the x value of the vertex, k is the y value of the vertex, and a is what's known as the stretch factor. We won't cover stretch factors in this class. You'll learn all about that in college algebra, but we will learn what h and k do. And we already know a little bit about quadratics, but basically all it does is take this x squared function, which is a parabola, and shift it side to side or up or down. So we'll come back to this one at the end. But first we got to learn how to complete the square in the easy case, which is when a is equal to 1. So completing the square is a process that allows us to rewrite expressions of the form x squared plus bx as perfect square trinomials, which can then be factored. In order to do this, we have to complete the square, hence the name. Okay, so x squared plus bx by itself is not a perfect square trinomial, but we can make it a perfect square trinomial by adding something to it that will make it a perfect square trinomial. All right, I've said that term too many times, but let's see how to do it. So when we want to turn x squared plus bx into that perfect square trinomial, we both add and subtract b over 2 squared, where b is the value in front of the x term. Okay, the new expression is going to read x squared plus bx, that was the original expression, but then we have plus b over 2 squared and minus b over 2 squared. So now why do we have to add and subtract it? Well, we want to have it equal the exact same value. So b over 2 squared minus b over 2 squared, this is equal to 0. So technically, by writing addition and subtraction of the same thing, I'm just adding 0 to x squared plus bx, which means I'm keeping it equivalent to what we started with. Okay, so now, once we've written b over 2 squared minus b over 2 squared there, then we want to do what the actual purpose is, which is to factor these first three terms here into a perfect square. Well, they already are a perfect square trinomial, but we want to factor them using that fact, and they're going to factor to be x plus b over 2, the whole thing squared. Okay, so right here, this x squared plus bx plus b over 2 squared, that factors to be x plus b over 2, the whole thing squared. So now why is that true? Okay, is what you should be asking yourself. Well, we have seen in the past that if we take a plus b and we square that whole thing, we get a squared plus 2ab plus b squared. Now, the only difference between what happens there, okay, where we take a squared plus 2ab plus b squared and factor to be a plus b squared, is that the b right here needs to be divided by 2 in order to make this magic happen. So notice that if we multiply out right here, x plus b over 2 squared, using that same formula that's on the right, okay, it's a different b though in this case. Okay, so this b and this b are not the same b. But over here on the left, if we multiply this out, we would get x squared plus 2 times x times b over 2. Okay, that's the 2ab part in the middle. And then plus b squared, which is b over 2, the whole thing squared. Those middle two terms, though, or sorry, that one middle term right here, simplifies because the 2 in front will cancel this 2 in the denominator. So this is going to be equivalent to just x squared plus b, oops, plus bx plus b over 2, the whole thing squared. So what happened here is that this 2x b over 2, the 2's canceled, so we just got bx there. All right, and so now notice that what I just wrote here, x squared plus bx plus b over 2 squared, that is the same as what we started with over here, x squared plus bx plus b over 2 squared. So these first three terms factor to be x plus b over 2 squared, and this minus b over 2 squared just stayed in the back. All right, so now let's put it into practice. Number one over here, we have x squared plus 10x. The process is pretty simple, okay? We're going to rewrite what's already there, x squared plus 10x, but then we are going to add 0 to this, okay? So don't write this part because I'm going to delete it, but I'm going to write plus 0. The thing is, though, I don't want to actually add 0 because, that doesn't really do anything, but I want to write something in that place of that 0 that's equivalent to 0. So instead of putting an actual 0 there, what I'm going to do is I'm going to add something and I'm going to subtract that same thing. So those two blank spots are going to be the exact same thing. And we already know what they're going to be. They're going to be b over 2 squared in both places. So how do we get to b over 2 squared? Well, we take the b term, which is 10. Okay, so right here, b equals 10. So b over 2 is equal to 5. We just divide it by 2. Now I square it. Okay, so b over 2 squared is going to be 5 squared, which is 25. So I write 25 in both blanks. Okay, so again, let me write these out in a little more detail so we can re-go through that process here, because this is the most important part of the whole process. Right here, b is equal to 10. Would help if I write 10 instead of 0. b equals 10, which means b over 2 is equal to 5, because we just divide both sides by 2. And that means that b over 2 squared is equal to 5 squared, which is 25. Okay, so 5 squared is what's going in both those blanks. All right, so now all we have to do is factor the first three terms. But you should never have to think about how they factor because they're always going to be factored to x plus b over 2, the whole thing squared. So in this case, that's x plus 5 squared, and then minus 25 in the back. So real quick here, what happened? If we imagine parentheses around these first three terms, they factor to be x plus 5 squared because that is a perfect square trinomial. Sorry about the keyboard. That's a perfect square trinomial right there in the front. So x squared plus 10x plus 25 is x plus 5, the whole thing squared, where I can do that really quickly because this 5 right here is always the b over 2 that we had from before, and the minus 25 just stays in back. All right, let's try it again. The only difference between number 1 and number 2 is there's a negative 65 floating around number 2. So what we're going to do is essentially just ignore it. Okay, so I want to rewrite number 5, or number 2 over here, as x squared plus 8x plus a blank. Okay, and then we have minus 65 plus blank. Oop, but I wrote plus instead of minus there. So let's put that minus sign on there. Okay, so now what is happening? X squared plus 8x minus 65. That's the original problem. All I'm doing is spreading it out a little bit, and then I'm going to add and subtract the same number. That way I'm not actually adding anything. I'm just making this look a little different. Okay, but I'm adding and subtracting the same number. That way nothing changes. So now we just have to figure out what number to add there. Well, the b term right here is attached to the x. So b is equal to 8. That tells us that b over 2 is equal to 4. And if b over 2 is 4, then b over 2 squared is equal to 16. So in both of these blanks, I'm going to put that 16. Where notice that these 16s would just cancel each other out if I were to simplify this, but we don't want to simplify it in that way. Okay, we are purposely making the equation look harder. That way we can now factor it to be a perfect square trinomial in the front, which will factor nicely, and we just subtract those two numbers in the back. All right, so now we're going to simplify this. The first three terms, x squared plus 8x plus 16 right here, those are going to factor to be x plus b over 2. And remember, b over 2 is 4, so this is x plus 4, and it's that whole thing squared. Then negative 65 minus 16 in the back is negative 81. Okay, and remember, you never have to think about how to factor it right there. The x plus 4 comes automatically because it's always x plus b over 2. So I just take that b over 2 and put it right there. And if b over 2 was negative, I would just have x plus a negative 4 here, which would be x minus 4, the whole thing squared. All right, we're going to make it a little bit harder now. When a is not equal to 1, we have a problem. Okay, to complete the square, like we just did, we need the leading coefficient to be equal to 1. If this is not the case, then we must first factor out the leading coefficient so that the remaining polynomial will have a leading coefficient of 1. So in order to do this process, we have to factor out whatever is in front of the x squared term. So when we look at number 3 over here, the fact that there's a 3 here is bad. Okay, so what we want is for this to look like x squared with a 1 in front. So the only way we can do that is by dividing by 3. But we learned how to factor things out, okay, in an earlier lesson. And so what we want to do is factor that 3 out to the front. We don't want to factor it out of everything though, because the negative 6 in the back, we're just going to leave alone. Okay, we want to leave this negative 6 alone because remember a second ago when we completed the square on number 2, okay, we left this negative 65 on the outside all by itself. We didn't mess with the negative 65. So right now when we're doing this problem, we don't want to mess with the negative 6. We just want to leave it alone. So what I want to do is think about this. Well, let me use the black pen instead. Think about it as 3x squared plus 8x in parentheses, and this minus 6 just kind of in the back. Okay, we don't really care about that minus 6. But now I want to remove that 3 from the x squared term. So what I'm going to do is pull that 3 out to the front of these parentheses. Okay, when I pull out that 3, the x squared term is just going to be 1x squared because I do 3x squared divided by 3 just gives me 1x squared inside. But I also have to pull a 3 out from the 8. And you might be thinking, but 8's not divisible by 3. And you're right, but that's okay. When we divide 8 by 3, we just leave it as a fraction. 8 over 3x. And that's okay. It doesn't have to be a nice number, but notice I didn't turn it into a decimal because in the next step, it's actually going to be a lot more convenient that we have a fraction here. Okay, so now we still have this minus 6 in the back, and now we want to go through the process of completing the square. So what we're going to do now is add some space. I'm not going to change anything in this step. I'm just going to write things a little more spaced out. So I'm going to write 3 parentheses 8 over 3x plus blank, and then end the parentheses, minus 6. And remember though, I have to subtract the same thing that I add in that earlier step. But now here's where most students mess up. If I just put the same blank over here as I did over here, I'm not actually balancing the equation out because one of those blanks is worth more than the other. Okay, this 3 that's in front technically is getting distributed to all 3 things inside. So in order to balance out the first blank right here, okay, in order to balance out this blank is actually 3 times that blank. So if I want to balance it, I have to then in the back side of this equation subtract 3 times that other blank. Okay, so in order to balance out this blank, which is being multiplied by 3, I have to subtract 3 times the other blank. All right, so now in those blanks, we're going to complete the square just like what we did before. So we're going to take the b term, we're going to divide it by 2, and then we're going to square it. So right here is the b term, 8 over 3. b equals 8 over 3. So that means that b over 2 is equal to 8 over 6, because all you do is take the b term, divide it by 2. So when we take 8 over 3 and divide it by 2, we get 8 over 6, but that's equivalent to 4 over 3. So instead of writing 8 over 6, I'm going to write it as 4 over 3, which is the reduced fraction. All right, and then now we're going to square it. So when we do b over 2, the whole thing squared, we square the top and square the bottom. So we're going to end up with 4 squared on top, which is 16, and 3 squared on bottom, which is 9. Okay, so that means that in my two blanks, I'm going to write 16 over 9 and 16 over 9. All right, now it's just a matter of simplifying. So most of the simplification actually happens almost automatically. So this whole time I've been telling you, you don't have to think about how to factor that first set of parentheses because it automatically factors to be x plus b over 2. This is where that really comes in handy, is you might look at that set of parentheses right there with this 8 over 3 and this 16 over 9 and say, I have no idea how to factor that. That's okay though. You don't have to know how to factor that because it automatically factors to be x plus b over 2. And in this case, our b over 2 was 4/3 right here. So all I have to do is take that 4/3 and put it into that blank right there. And it's that whole thing squared. Okay, so I did not go through any process of factoring just now because I already know that that perfect square trinomial will factor to be, since the first thing is x squared, this is x, and since the last thing is 16 over 9, this is the square root of that, which is 4 over 3. So it always is x plus b over 2 right there. All right, now the somewhat tedious part of this is we have to add together those fractions in the back. So we're going to do that in 2 steps here. Right now we have -6 minus, and then if I multiply 3 times 16 over 9, it's going to reduce the denominator to be a 3. So this is 16 over 3. Okay, because I just reduced the denominator right here, 3 times 16 over 9. The 3 on top cancels and puts a 3 on bottom. So now we have to actually add those together. So usually when I add fractions, I do it on the side, but this time I think it's going to be a little easier to do it in line. So the first part of this equation I'm not going to touch, just leave it the same. Then I need to rewrite -6 with a common denominator of 3. So -6 is actually -18 over 3, because I multiply it by 3 and put the 3 on bottom also. Remember, 6 is really 6 over 1, so you multiply top and bottom by 3. And then we're subtracting 16 over 3. When we do that subtraction, real quick, the front is going to stay exactly the same, x plus 4 over 3 squared. But then we do 18, -18 in this case, minus 16 is going to give us -34 over 3. And that's it. That's our answer. So now again, you're thinking, why would I want to do this? Why is this better? And that's okay, because we have a purpose, okay? When we talk about quadratics later in this class, lesson 26, this is going to be useful because it shows us where the vertex of this parabola up here is. And we will learn all about those terms in just a couple lessons. But understand, we need this skill for later. All right, let's do another one. This one's actually a little bit easier. The reason I say it's easier is because when we factor out the 2, we don't get a fraction. And I know you guys don't love fractions. So what we're going to do is start off the same. We want to get rid of this 2 in front by factoring it out of these first 2 terms. Okay, so we want to rewrite those first 2 terms with that 2 pulled out. So instead of 2x squared minus 16x, I'm going to put the 2 in front. And when I pull out that 2, 2x squared divided by 2 is x squared. And -16x divided by 2 is -8x. But notice that I'm just going to leave this -96 alone. Okay, I just put it on the outside. It's minding its own business. Now I want to add some placeholders. because I need to complete the square, so I need blank spots to do that. So I rewrite the 2 parentheses x squared minus 8x. I'm going to write plus blank, and then end the parentheses, and then minus 96 minus blank. But remember that this other blank right here has to cancel out the first blank. The way I wrote it right now, that doesn't happen because this 2 in front is actually being multiplied by this blank. So in order to properly cancel out that first blank spot, we need to multiply the second blank by 2. So I put a 2 in front of that other blank. Okay, this is extra important. You balance out your equation, otherwise you're changing the value of it. Okay, so now to complete the square, we need to figure out what's going to go in those blanks. So right here, the b term, our b value is equal to -8, because it's the coefficient of the x. If we take -8 and divide by 2, b over 2 is equal to -4. And now we're going to square that. So b over 2, the whole thing squared, is equal to positive 16. Because we take -4 and when we square it, 2 negatives make positive. So I'm going to put positive 16 in both blanks. All right, now we're going to factor that perfect square trinomial. Well, remember, you don't have to think about how to factor it. It's always x plus the b over 2 value we had before. So in this case, it's x plus -4. So I could write x plus and then parentheses -4 like that. But whenever you have plus and negative, we're just going to jump straight to x minus 4 right here. Okay, so plus -4 is the same as x minus 4. We square it. And then in the back, we still have -96 minus, and 2 times 16 is 32. So I now need to just combine those terms in the back, and then we'll be done with this one. So 2 parentheses x minus 4 squared, -96 minus 32 is -128. And that is now a factored version of the equation at the top, or the expression, I should say, at the top. Now we have just one more, and it's on the title slide. Very similar to the 2 we just did, but it tells you the reason that we're doing what we're doing. So in college algebra, we need to be able to write quadratic functions in vertex form, which is exactly what completing the square is for. We also use it, by the way, in pre-calculus. When we talk about conic sections, like circles and ellipse, we want to be able to rewrite general forms of those using completing the square into a similar format as what we're doing here. But for sure, and in the next class, you need to be able to do vertex form of a parabola. All right, so we're going to take 3x squared minus 12x plus 9, and all we're going to do is the same steps as before. So I see a 3 in front, so I'm going to put parentheses around these first two things, and I'm going to factor that 3 out. When I do that, I'm going to get the 3 in front, and inside those parentheses, I pull out the 3 from the 3x squared to just get x squared. Negative 12x divided by 3 is -4x, and then I leave that plus 9 alone in the back. Now I'm going to add some space to it. So x squared minus 4x plus blank. Then I have plus 9 minus blank. But remember that I need to balance this equation, so the 3 in front has to also go in front of this second blank in order to keep them equivalent. Now our b term in this case is -4. So I take -4 and I divide it by 2. Okay, again, b equals -4, which means b over 2 is -2. When you square -2, we get that b over 2 squared is equal to +4. So I put a +4 in both blanks. Now all we have to do is factor and simplify, where remember the perfect square trinomial always factors to be x plus b over 2. In this case, b over 2 is negative, so we get x minus 2. Instead of plus -2, we jump straight to -2. Okay, then we have plus 9, and minus 3 times 4 is 12. So then we just finish this off. It's 3 parentheses x minus 2 squared, and the 9 minus 12 gives us -3 in the back. And that's it. We have now put a quadratic function into vertex form which again in lesson 26, we will see why we're doing that, and we'll actually make some use out of it. All right, thanks for joining me, and I'll see you next time.